In today's session, we'll understand an interesting and easier useful item, data frames and transformations. What are these? Let's understand. Data frames are actually virtual tables that we have been creating and using all these days in our examples. We learned how to create tables. Let's just put this way back to our notes. In our examples, we have been learning how to create data frame, say spark.read.csv. We got one data frame, aggregate the data, then another data frame to load the data, one data frame to capture ADLS data, another data frame to store the data into Spark DB, temporary views, or data frame to write data to SQL database. So at every box, entry point of every box is all about data frame only. We have been creating data frames, performing operations, again another data frame loading it, df.write.parquet or df equal to spark.read.format, spark.read.csv, etc. So every day, all these examples, we have been creating data frames using existing tables, existing ADLS file source. We created data frame using tables, query result, and we created data frame using file source, DBFS source and file source. Today, how to create data frame manually. Small example to start with. Import pandas library. Okay, it is used to work with data frames. It's a library to work with huge volume of data set. It has functions. It has functions like merge, concat, etc. For easy data classification, easy data merging, concatenations, and other operations, we have pandas library. Let's create one small data frame first. There is one function called data frame function. What is that? Data frame function. This data frame function needs one variable that has values. So this is the variable. Nothing new. Really, friends, nothing new. You practiced Pyspark widgets. In Pyspark widgets also, you gave a similar list for drop down values. I repeat again, Python widgets concept, Databricks module, few classes back. Widgets are parameters. There we got Spark table v1, Spark table v2, Spark table v3, etc. in the list. That kind of list we are defining first. That list is taken to a data frame, pd.dataframe. What is pd? Pandas library reference. Pandas library has data frame function to create a data frame and print data frame. This is the internal structure of data frame, and we have been using data frames in all these examples so far. But this is the actual internal structure wherein there will be index 0 first value, index 1 second value, index 2 third value, so on. Next, there is an extra index for internal reference. One more example. You would like to have a mixed list. Earlier string list, string values. Now mixed list. name colon age colon. See here, data is equal to, in curly braces, see the representation carefully. When there are more than one list, we need to give it in curly braces. This is important for us to remember. This is one list, okay? And this is another list. List 1, list 2. This is taken as one mixed item, mixed list. Then what next? Create another data frame. What's the specialty here? This is nothing but a table. See there? Header. This is the header. In earlier item, there is no header, right? So you got zero header. Internal reference, internal column index. This is a row index. Here it is. Left side row index, right side column index. In this list, there is no column header, so it takes 0 automatically. Whereas in this example, we see meaningful header. Observe carefully. Next. What else? Let's create. Now, this is about data frame creation. Two different styles. Meaningful header, default header. Now, our actual concept. How to get into transformations. Let's see. Import data frame, pandas data frame, PD, or any reference name of your choice. First data frame, employee column, values. Department column, values. Second data frame, employee column, extra value. For these existing values, I am changing, zigzag the order, extra value. So because there is an extra employee, extra salary, I said extra, right? I am Sai, extra employee for your company. So my salary is 0. Let's print both. Semicolon not required. And we are able to see data frame like this. Display. See here now, print means plain text. Print data frame means plain text. Display data frame means like a select statement, right? Table. Observe carefully. Then what else? I would like to append. I would like to append. Concat is a function to bring the values for data frames one below the other. And here you see 012, 012. I mean, these values, the indexes are being maintained. I said index starts from 0, right? That 0 index is being maintained as is. You would like to continue the index, then we say ignore index equal to true. You would like to concat. You would like to union. Concat means here union. Union the data frame result. One below the other. Union. And ignore index equal to true means index values like this. Next. Other important one. Merge. Merge means one beside the other. Remember, concat means, hope you are writing your running notes as usual. Good to have it handy for easy future reference. Quick, simple reference. Concat, one below the other. Merge, one beside the other. Here it is. Merge means inner join. Remember, only matching 3 employees will be reported. I am your extra employee, salary is 0, Sai. It is not there, right? I repeat this one. The extra employee Sai is missing in the first data frame, no matching. So I don't expect it here. It's not there. Next item, how to join more than 2 data frames, just like joining more than 2 tables in your favorite SQL. Assume there is third data frame, once again employee and locations, and joining more than 2 data sets, we need to merge first and second. You get one result. That result should be given to second merge. Join result 1, comma data frame 2 gives you third join result set. This is also actually data frame. Okay, this is a data frame actually. Joining two data frames will result in data frame only. So I'll just mention like this, in this way, DM in this way. Observe carefully now. So we are bringing data from multiple data sets. First data set has employee and department. Second data set has employee and salary. Right? Here it is. First data set has employee and department. Second data set has salary. Third data set has location. This one. Bringing everything together. Merge means inner join. Inner join occurs based on the matching column. Employee is the matching column. Right? Here it is. Employee is the matching column. Observe carefully once again. Employee. Same way, third data frame also employee. What if data frames don't have matching columns? Merge won't work directly. Alternative, we can specify on column name, whether you wanted to join based on employee or aircraft code or customer key, product key, sale ID, whatever. Provide on keyword. Observe carefully now. I'll wait. This is about inner join. What if you would like to do some outer joins? We can mention inner join specifically. Remember, it is case sensitive. If I say inner, it won't work. It won't work. Keyword, say key error inner. Remember. Okay. I have to mention lowercase only. Same way left. All left matching right. All left matching right. In our example, right side, I had an extra employee called Sai, right? This one, see here. For Sai, there is an extra employee called Sai on the right data frame, right? Second data frame. So, department is taken as NAN. I'll provide you examples how to replace NAN. Some additional examples for your more practice. Next, let's continue. Here it is. We can replace NAN with 0 or whatever value you want, okay? Next. With this, there are functions like fill NA function, replace function, etc. I'll provide you those examples as well anyway in the class notes. You'll be receiving some extra items. If you are looking for more on Python, you got extra examples for quick reference. Then comes right join with on table name. Same way we have full join, right? Full outer, self join. Self join means same data frame being repeated. Once you practice these items, creating data frames, joining and concatenating data frames. Then you practice one more important item, upset, also called SCD, slowly changing dimension, nothing but incremental loads. Merge, upset we call, upset, merge. Before we proceed, let's wait, okay, please wait. Yeah, here it is. Assume there is some data like this. This is one list and this is another list. Okay, list 1 data, list 2 columns. We can create a data frame from those two lists. See here now, you bring them together like this. Columns should be in the second place, data should be in the first place, and their items should match. Here I gave data for 3 values, right? So only 3 columns should be there, then it works. So remember 2 items, okay? Data comma columns. Data first, header last. Header means column. Remember this rule, data first, header last. Then you get the data frame ready. This is another way to create data frame from multiple lists. Next, let's understand Spark. So far we are learning only data frames. Now let's touch base with Spark tables. Let's create a Spark table for incremental loads. Firstly, before I planned the session, I tested it to make sure we save time. I tested the items, so let me just drop them. Well, I dropped them, everything is fine. Firstly, let's create a Spark table. For our easy learning, percentile SQL, small case, create database Spark DB for SCD. Let's create one database first. And percentile SQL, use database, this database name. Next. This is just for reference, so in case you would like to practice more number of times. Okay. Now I'll just bring it down. Okay. For your reference purpose only, I'll just move it down. Again, move it down. So inside your database, if table already exists, just in case, for reference purpose only, you may ignore this one. Now create table. I am in Python notebook because we started with data frames. Let it be. You can even change the notebook environment here. For now, leave it as it is. Create table, table name. Our requirement to prepare the tables for delta, mean incremental loads. I create orders table. Same way, I create inventory table. Attendees from our SQL concepts. Joins chapter number 7. Attendees are not from SQL, no problem. You're already aware of joins, right? Same thing. Orders, just in case for easy reference. Orders table, inventory table. Orders, inventory, insert the data 1, 2, 3. Orders 1, 2, 3 IDs. Okay, this one ID, order ID 1, 2, 3. Same inventory ID 3, 4, 5, 6. Now we got our data ready. There are 4 rows. And we can also have a select statement. Let me just include a select statement here for clarity. Percentile SQL select from what is that? Spark SCD dot orders, and okay, we are able to get order ID, order department, quantity dot inventory. This one, inventory. Here, whenever you plan to go for multiple select statements, we need to have semicolon separator, and we see second result only. We don't see first select statement result. It's simply overwritten, remember. So what I do? Syntactically, this is correct, but practically, it is recommended to have a separate additional cell percentile SQL for inventory like this. Now our next step, what we need to do? We need to compare orders table with inventory table. See here, this is my orders table. Okay, ID, department, quantity. Now see there carefully. Order ID, inventory ID. Order department, inventory department. Order quantity, inventory quantity. I would like to compare order ID and order ID, inventory ID. 1, 2, 3, 3, 4, 5, 6. 3 is common. For matching data, you would like to do some DML operation. For missing data, you would like to get them inserted to destination. These two were missing, right? They are at the source, but not in the warehouse. You would like to get them inserted, something like that. How? Let's see. There is one statement called merge statement. Just like your regular SQL Server T-SQL, here also you have merge. There we say in T-SQL we say merge target. Here merge into target. Merge into target using source. Remember, this is target table. And what about this one? This is source table, like this. Source table is also called reference table. Remember, Python notebook we use pound symbol, hash, pound symbol for commenting. SQL notebooks we have to use hyphen symbol. Merge into target using source on condition, and when matched, then update. What to set? Say quantity you would like to update, department name you would like to update. The target table, inventory and quantity, they get the data from orders table, source table. What if there is no match? Insert into inventory values. Which values? Order values. That's it. Same as transact SQL script. If you are from Oracle, in case if you are from Oracle, I kindly request you to have a look at our website, Transact SQL T-SQL content. You're already aware of it. Need not join any course, not required. But during your free time, please see if you can revise, if possible, revise merge concept. If you're from Oracle or MySQL or Sybase, please revise Transact SQL merge. Then it will be more fruitful, easier. or you may even opt for our live training, the 3 weeks live training for Transact SQL if required, or you may even go for the self-paced video course and complete within a week at your own pace. Anything, same, either live or video, same content, same curriculum, same example, same task item, same scenarios. Anything is fine. We'll continue. Where we are now, merge target using source on condition. When match, update, not match, insert. That's it. Okay, I executed this few moments back. How do you verify? Select from target. Okay, select from target. What's the target here? Inventory table. And you see here 3, 4, 5, 6. Okay, but 1, 2 also got inserted, right? I'll simply say order by, to make it more easier, order by inventory ID in ascending or descending. So initially we got only 3, 4, 5, 6. Now we have 1 and 2 also. From where they got inserted? From orders table. Orders table as 1, 2. Inventory table as 3, 4, 5, 6. Merging together, we got 1, 2, 3, 4, 5, 6. So what we are learning here? How to merge tables. From this concept, once you practice all these items, task 1. You have an ADLS source for orders data. You have a DBFS source for inventory data. How to merge using Pyspark, or how to merge using, simply say, Databricks notebooks. This is your first task item. You got orders table, inventory table directly in Spark table format, right? Now you please try to do this one. ADLS source, DBFS source. Next, task 2. How to load above result into Azure SQL Database. Option 1, using Pyspark. Option 2, using Scala. We did these examples individually. Now you will combine them together. Task 3. For above example, how to parameterize the input ADLS connection info, and how to parameterize the output Azure SQL Database connection info. This is the actual concept. Apply it for different result and apply it for parameterization. Task number 4. How do you, as a data engineer, how do you optimize above notebook, and how do you secure them? Okay, these are the task items. You will give a try. Try them. You should be able to do it yourself. If you want my corrections or my reference, just mail me. But anyway, you will be able to do it. You are able to test it. It's fine. It's not something that is really mandatory to submit. No, you try it, you test it. You are able to get happy. Any error, please let me know. I am there. Now, I shall export the notebook, provide you all this content. I shall export the notebook and provide you all this content. Make sure you practice these items carefully as is, and do let me know for doubts, clarifications if any. Try to work on these task items also. I shall include these task items as well. Let me just save it here. I'll say Databricks tasks from DataFrames. I'll just mention this one. Please kindly practice the things carefully, because we need to involve in a project. A nice project is waiting for us, really. And the project, you need to work on good number of integrations. I need to provide you the solution step by step for the project. If our interviewer asks us like what we did in the project, we need to explain them what is what, when we are doing what and why and so on. And we need to also get into few other additional FAQs like the process orientation and a small blueprint. Different data sources with and without Spark database, we are using Databricks. In our example, Scala example, and even the task item today, I was mentioning Azure SQL Database. But our next level, you will be doing SQL Pool. Very simple. Replace SQL database name with SQL Pool. That's it. Synapse. This is the overall prototype of our project. Whatever task given to you today is ADLS to Databricks to SQL database. You can even use SQL Pool. We'll do one by one, step by step anyway. I'll guide you for that. Please practice the things carefully on time so that we are ready for the next activity.